We know how to differentiate polynomials, logs, exponentials. The next set of functions, our trig functions. Let's see how we differentiate this. I'm going to start with some limits that are going to be very useful, and they're obvious when you think about them. If you think of the sine curve as the x value is approaching 0, well, we know our sine curve is approaching 0 as well. The cosine curve would be approaching 1, and the tan curve would be approaching 0. I might not end up using all of these, but there's our three basic trig functions. That's a circle, by the way, in case you're wondering. Okay, what I do know is this. I can work out the area of that sector there. We saw that. We've got a formula for it. X we would like in radians for our formula to work, of course. Now, if I was to draw in the chord, I know the area of that sector must be greater than the area of that triangle. I could create another triangle by drawing in a tangent. Okay? So we get a right angle triangle. I could work out using basic trig that the height of that triangle would be the tan of x. But the area of that triangle must be bigger than the area of the sector. Okay, well, let's work out these areas. Using our formula, the radius of our circle, conveniently I've made 1. So tidying that, I get that x must be in between sine x and tan x. So the actual angle in radians will always be in between the sine of that angle and the tan of that angle. I'm now going to divide everything by sine x. Well, when I do that, I now get this little one. I've trapped x on sine x in between 1 and, well, it's sec x, but I've written it as the reciprocal of cos x. So as x approaches 0, remember we said cos x approaches 1. So as x approaches 0, I have trapped x on sine x in between 1 and 1. Therefore, I now know that the limit as x approaches 0 of x on sine x must be 1. And that's what I actually mentioned yesterday, what we call the small angle theorem. As x approaches 0, because I could rearrange that, x would equal sine x. So if I had to find this sort of limit, so x approaches 0 of 5x on sine 5x, well, if x is approaching 0, 5x must be approaching 0 as well. So it's just 1. The key is to make the algebra match the angle, because that's what we know, sine x on x, the angle is the key. So if I have x on sine 3x, I say, well, I don't know that limit, but I do know 3x on sine 3x. That goes to 1. I got a third of that, so this limit must go to a third. Let's have a look now at sine x. We want to know how to differentiate this thing. Now, starting point, first principles. We get the limit as h approaches 0 of sine x plus h minus sine x all over h. But of course we know sine is sine cos cos sine. If it's the sine, it's the sine. So I get sine x cos h plus cos x sine h minus sine x on h. Remember, the limit we know at this stage is x on sine x, or its reciprocal would also be 1 sine x on x. So let's pull that out, because that's the limit I know. Well, the cos x is fine. If I just pull that out, I've got cos x times sine h on h. As h approaches 0, I know that's going to go to 1. What am I left with? I've got sine x times cos h minus 1 over h. Don't quite know that limit yet. I'm going to have to play around with it. So I'll use double angles. So instead of looking at it and seeing it as cos of h, I'm looking at it and seeing cos of twice h on 2. Well, that will be 2 cos squared minus 1, but I have another minus 1 there, so it becomes 2 cos squared minus 2. How's this going to help me with our limits? Cos squared minus 1 is sine squared. So 2 cos squared minus 2 must be 2 sine squared. Now we're getting closer to having something we can work with. But my limit is not sine squared on h, it's sine on. So I factorise out the sine. I rewrite that 2 on h to make it a bit more obvious as h on 2. So the angle is matching the number. Now I'm okay, because I can sub 0 into everything now. Because that first one, sine h on h, that goes to 1. The sine h on 2 and h on 2, that goes to 1, but it's multiplied by the sine of 0, which is 0. I've got cos x times 1 plus sine x times 0, so the derivative of sine x is cos x. So sine goes to cosine. So to generalise that, if you've got the sine of any function, basically you differentiate the function, put that out the front, the sine goes to cosine, the angle does not change. So it's the angle that you're differentiating, put the derivative out the front, but the angle itself does not change. Well, from there it should be easier, because now that we know that, let's work out cosine. But all I now know is how to differentiate sine. But I can change cosine. I can write it as the sine. Remember, we're talking about radians, so pi on 2 minus x. But I now have a formula that allows me to differentiate that. Differentiate the angle, I get -1. Sine goes to cosine. The angle does not change. But the cos of pi on 2 minus x is sine x. And that explains why when you differentiate to cosine, you get negative sine. So to generalise that one, so again, you would differentiate the angle. It goes out the front, but it's negative, the derivative. Cosine goes to sine. The angle does not change. Okay. Tan. I now know how to differentiate sine. I know how to differentiate cosine. Tan I can rewrite as sine on cosine. Quotient rule. Square the bottom, write down the bottom. Diff the top, minus write down the top. Diff the bottom. Something lovely happens. On the top of the fraction we get cos squared plus sine squared, which of course is 1. And the reciprocal of cos is secant. So when we differentiate tan, we get sec squared. So that explains why all of a sudden it becomes a squared trig function rather than a straight trig function. So tan goes to sec squared. To generalise that one, again, differentiate the angle, that goes out the front. Tan goes to sec squared, but the angle does not change. Alright, we won't worry about the reciprocal ratios for now. Let's just do some examples. So I get the sine of x cubed. Differentiate the angle, 3x squared. Sine goes to cosine, angle does not change. Straightforward as that. The tan of 1 on x. Differentiate 1 on x, I get minus 1 on x squared. Tan goes to sec squared, angle does not change, 1 on x. The log of the cosine of x. So it's a log function that I'm differentiating. Differentiate log. Derivative over the function itself. Well, the function is cosine, goes on the bottom. The derivative of cosine is negative sine. So I have negative sine on cos. We can do better than that because sine on cos is tan. So we get negative tan x. Tan to the power of 5. Anarchy. Bring down the power. 5. Lower the power. It now becomes tan to the power of 4. Diff the inside. Well, the inside is tan x. Differentiate tan. You get sec squared. So 5 tan to the power of 4. Sec squared. The swimming question. We differentiate the angle. Differentiate e to the x, we get e to the x. World's easiest derivative. Cosine goes to negative sine. Alright, there's some questions. Let's work on those.